Hello everyone, my name is 𝐆𝐫𝐞𝐞 and with this video we are going to start our new series in which we are going to learn all about greedy algorithms and how we can use these greedy algorithms to solve our particular problems. As you guys already know, it is frequently asked in competitive programming and your DSA level problems, your OAs and interviews. The greedy algorithms is the most asked problems, the most asked algorithms on any contest you see on Code Forces and AdCoder, and the problems of A and B problems, the starting few problems of every contest, every competitive programming contest usually include greedy algorithms. So you guys already know the weightage of these, how important is it to study greedy algorithms. But the problem with this is greedy algorithms is, as you guys already know, and you guys already know about greedy algorithms, it's nothing new, it's very simple algorithms, but I will give you the definite path and how to solve these particular algorithms. Why I am saying you already know greedy algorithms but you are not able to solve greedy algorithms problem, because we just learn in a very standard fashion. We don't learn it in a proper way. That is the main problem that arises for our greedy algorithms. And with this particular course, I guarantee you that you will be able to solve very difficult problems of greedy, very easy problems of greedy. And you guys already know, even 2000 rated problems comes from greedy. So it is not a very easy topic, and as per se, it's not a very difficult topic. We can say it is an intermediate topic, but it is very essential to cover all of this. So with this particular series, what you can expect is, how are we going to proceed with this? So with this first video, we are going to learn all the theory about greedy algorithms, all the important theory about the greedy algorithm. And as you guys already know, greedy is not about theory. Greedy is all about practical implementations, the exercises and all. But the theory is very important, and you will get a very unique kind of a theory here. I am not going to just tell you greedy to choose the best possible at the moment and those kind of things. I know that you already know all of those things, but I will teach you a very unique concept like invariants and monovariants, how we use them to solve the particular problems, how we use greedy to solve a particular problem. That's the whole things we are going to cover up in this particular course. So before we start with the greedy algorithms, I just want to tell you a few things about the mathematics approach and the which we learn, the problems we learn. We have some ad hoc type of problems. What are ad hoc type of problems? Which are, we don't know a specific approach to solve these types of problems. What are ad hoc type of problems? The problems we don't know a specific approach, this is a definite approach to solve our problems, or we have graphs. So we know that we have in graphs we have two algorithms, for graph traversal DFS and BFS. We know that we can use DFS or BFS to traverse the whole graph and find our solutions, different algorithms. But the ad hoc type of problems is, we do not have a specific approach or an algorithm to solve this, but a lot of different problems can be solved, a lot of ad hoc type of problems can be solved using greedy. And this is what we are going to cover, how we can use greedy to solve a lot of ad hoc type of problems, and we can build upon that. And I just want to tell you one more thing. I want to tell you a difference between some things. A lot of people who comes from a mathematical background, who knows about the mathematics Olympiad and all of those things, I already will know there's a difference between an exercises and problem solving. That's a very crucial thing, and this is very important to differentiate between these two things. Exercises, what are exercises? You learn a simple formula. Which is A plus B, addition. You do A plus B and you get something different quantity. So any problem which comprises of addition, you will take the left hand side of the quantity and the right hand side of that, and you just add them, you just sum up and you will get your final result. This is what we call exercises. And what is exercises? We know an approach. To solve that particular problem. That's the main essence of what is an exercise. We know an approach, we practice more and more, and we finally get to our final result. But what is problem solving? Problem solving is the problems which we solve for those problems for which we don't know any approach. We don't know any approach. What is the meaning of this? Like the ad hoc type of problems, we don't know how to solve these. We have to develop a problem solving skill, we have to develop our problem solving skills, and to solve these particular problems we don't know an approach to that. That's the main difference between a problem solving and exercises. So the main problem that arises with all of you guys is like why are you not able to do well in competitive programming or DSA as per se? It's not because these things are difficult, it's because we are not studying them correctly. We are just focusing on exercises, we just learn an approach and we are just doing more and more exercises. When a different problem comes, we are not able to solve, because competitive programming, the problems comes are the problem solving type of problem, not the exercise type of. Exercise also comes, but the problem solving is what mostly which comes. So my main goal with this particular series and with the constructive series I am going to cover up next, my main approach is to help you navigate through the problem solving approaches. Like how do you proceed when you don't know a particular solution of a problem, when you don't know a particular approach of a problem. And the first thing we are going to learn about all of this is the greedy algorithms. What are greedy algorithms? Simply, greedy algorithms are not a specific algorithm like these are the definite step, you follow these steps and you will find a particular solution. Like no, that does not happen in here. So how do we learn greedy algorithms? We do a lot of examples, we develop techniques and we like master some of the tools, and then we slowly gradually build up to that problem solving skills, and then we solve the greedy algorithms. So with this like a brief understanding of what is exercises and what is a problem solving, let me just start with the greedy algorithms. So what is a greedy algorithm? Greedy algorithms are the algorithms that makes the choice based on what is best at the particular moment. We will like take step by step, and you will get all the notes of this in the PDF section, as a PDF in the description below. You can get from there. So let me just start what is this and what are greedy algorithms, and we will build up step by step, we will build up proofs and everything we will do. So what is the greedy algorithm? Greedy algorithms are the algorithms that makes the choice based on what is best at a particular moment. What do you mean by this? Makes a choice which is best at that particular moment. That is a very important thing, at that particular moment. What is the at that particular moment thing means? Like you are in a state, one, you are solving a problem, you like get to a state 1, and you have like 3 different options. You can go to a state 2, you can go to a state 3, you can go to a state 4. And what the greedy is saying you, greedy tells you to just pick the best among all of these. You have the options, you can go to the 2, you can go to the 3rd state, you can go to the 4th state. What greedy is saying you, go to the best state at that particular moment. Don't like consider what will happen in the future. Like if you go to the state 3, then you can go to different states. If you go to the state 4, you can go to different states. If you go to the state 2, you can go to different states. And you don't know like choosing that particular moment at the best particular moment, how will it affect in the future. That is the one thing we will discuss later. But the greedy, what greedy does, it just picks the best at that particular moment. So what is the best at that particular moment? Like just say like the 3rd state is the best at that particular moment. So you just go to the 3rd state, you don't go to the 2nd, you don't go to the 4th, you went to the 3rd. Then for example, you have like 6, 7, 8. These are the states moving forward. Then like the 6th state is the best, you don't go to 7, 8, you just get to the 6th, and then finally gradually you build up to the solution. So what did we did in the greedy? We just pick the best possible option which is in front of us at that particular moment. That's the very first and a very basic implementation of what is a greedy. Second, we look at greedy algorithms are looking for maximizing the short-term gain. They are maximizing the short-term gain. They are not thinking about the long-term gain. What are the long-term gains? Like you start with the 0th index, you went to the nth index, you have a lot of options to go to there. You are not thinking about this whole long game. Which is the long gain or long game, whatever you want to say. You are not thinking about this. You are just thinking short-term. And what we call about the short term also, like a technical term will be a local optimal option. What is the best at that particular local optimal? You just choose that and you move forward with that. So you choose a local optimal and then gradually build up the solution. So at each step you are maximizing the short term gain and never takes back its choices, which makes it very efficient. Next point for us is the greedy algorithm never takes back its choices. What do you mean by this? Like you are doing greedy algorithms, you are this state, you went to this, you went to this, you went to this, you are moving forward, but you never take back. If you have make a choice, you never take back, you stand on your words, you stand on your tongue, and you just move forward. You don't come back and move to the next direction, you don't then move forward. If it fails, you move back, you go to the different direction. That doesn't happen in greedy. If you made a choice at that particular state, you only move forward, you don't move backward. And that is the one thing that makes it very efficient, that makes it very fast. That's why the greedy algorithms are very fast, very efficient, because they don't take back. They just move on with their choices and they directly construct the final solution. Using those choices, they directly construct the final solution. So in a very brief sense, like what is a greedy algorithm? Greedy algorithm makes choices with what is best in front of them, and you making those choices, they slowly gradually build up to to their final solution, and doing so they never take back. And the thing that they never take back makes them very efficient. That's why they are very efficient algorithms. So that's the very basic understanding of what a greedy algorithm is. We will move forward and understand them very in more detail. Like the simple things is, when we are applying greedy, simple thing we can think is like on what things we are applying DP. Simple one thing you can think of it is on what things are you applying greedy, and we will discuss about them. But a very general term is like you are what you are applying is the idea of looking at extreme elements. You are applying greedy and you are looking at the extreme elements. What can be the extreme elements? Like the biggest, the smallest, the best, the worst. In some respect, is the central to this approach. The greedy approach we discussed. We choose the best possible solution. We choose the best possible choice, or best possible option that is in front of us. Then we will slowly, gradually move ahead. And the idea of extreme elements is very simple. What are we choosing from? We are choosing from the extreme elements that are the biggest, smallest, the best or worst in some respect. And this is like the central to this approach. Greedy does not refer to a single algorithm, but rather a way of thinking, which is what I'm telling you from the start. Like greedy is not a single algorithm, does not refer to a single algorithm like these are the steps you follow and you will get to your final result, but rather a way of thinking, like how you can think of a particular problem, and that makes it very difficult. Some people are not that good of the way of thinking, like how can you think in the particular sense in like the problems that come in the competitive programming or those kinds of problems, how you can think about them. That's a very crucial part of any competitive program, and that makes you a better competitive programmer. I'd rather say that. So let's discuss a bit of a difference between them also. Like what is a backtracking? In a backtracking sense, in backtracking algorithms, what we usually do is we start from a particular state, we went to the other, we made a different choice, and we made to a final destination. Like we can't make any further choices from there. So we check there. What we check is either we went to an optimal solution. If this is an optimal solution, we get an optimal solution, we just return to our answer. If not, we backtrack and move to our next state. Like for example, these can be the next state and this is the final state. We then check, okay, this is the optimal, okay, we check if it is an optimal and this is the best solution. If it is not, we again backtrack, and for example, this can be our new path. We went, and if we find our particular final answer and this is the best solution, the optimal solution, we just return here, and we can say that we got our final optimal solution by backtracking. How did we backtrack? We went through a one path, which did choices during a one path. We get to the final result. We check that whether it is an optimal solution or not. If it is not, we backtrack and then we move to the different path. Then we backtrack, then we move to a different path. So that's what is a backtracking type of thing. Then we have complete search, which is a complete search or brute force. Complete search or brute force. What are these things saying to us? Complete search is it will search to every possible combinations there are. Like for example, there are n number of combinations possible. So a brute force solution, a full search kind of a solution, complete search kind of a solution will examine all of those combinations, all of those paths, and then derive the final result. That makes it very slow. But a greedy approach, it just makes the local optimal choice at each stage and just move forward. That's what makes it a very fast algorithm. So I hope you get a brief idea of what is a greedy algorithm, but we will discuss more. And what we will discuss is like how we can prove them, these algorithms, and all of these things. Like you will get them. So the next important thing that we should be discussing is, why should we learn how to greedily think about problems? Why should we bother thinking about the greedy solutions at all when we have better algorithms, we have better data structures and all of those things, techniques? Why we are doing the greedily approach? Like as I already said to you, like greedy, it never takes back. If it makes an optimal solution choice, if it makes a local maximum best choice at a local maximum, it never takes back. It moves forward confidently with that and directly constructs the final solution, which makes it very faster. And it can also be a substitute for some algorithms, as since it is a very fast algorithms, like the fractional knapsack type of a problems and the minimum spanning tree types of a problem, we can solve them very efficiently using greedy approaches. That's why it is very important for a greedy. That's why we study greedy approaches. And next we can think about it. What for greedy to work, the problem must have, like we have discussed like what is greedy, how we can apply greedy, but what are the problems? Like we can't just apply greedy to every problem. So what are the type of problems that greedy we can apply is, we have to check like these things. The first and the foremost, like the first important thing is greedy choice property. Making the best local choice leads to global optimum. The greedy choice property. What is a greedy choice property? On what terms we are applying greedy? Like either we are maximizing profits, either we are minimizing times or the deadlines or something like these types of things. Do we have a greedy choice property? If we have, then we can think about a greedy approach, and then we will think about as an optimal substructure type of problem. What is an optimal substructure? Like optimal substructure, simply said, we can solve a problem and that will help us build to the different larger problems. Like we solve a smaller problem. What is a smaller problem? Making a choice at that particular moment, making the best possible choice at that particular moment, and then from that smaller problem we move to a larger problem, then move to a much larger problem, then to a final problem which will give us the final result of that particular optimal substructure. That just gives us the final result. If both of these property holds, like a greedy choice property, we have a greedy choice, like we have something, we can apply greedy, we can choose greedily, and so that will be the first thing we have to discuss. And then we will think about the optimal substructure. What is an optimal substructure here? Like small solutions from the smaller subproblems can be used to solve the whole problem. We solve a smaller subproblem. Can solving those smaller subproblems help us to build a whole solution? That will be our next thing to discuss. So what will be the general approach to solving a greedy problem? That this is a very important of like the full lecture, the full course, what we will be discussing throughout, and this is very important like here. So the first step for solving the problem using a greedy approach is to do the problem analysis. Like this is a very important thing to understand the problem deeply. Like what are you optimizing from? For example, minimizing time, maximizing profit, or minimizing number of items. This is very crucial and this is very important. For like if you give contest on code forces, like the A and B problems, you have to like very deeply study those problems, deeply understand what these problems are asking, what the problem is asking. Like then you can optimize things, like you can optimize using the minimizing time, the maximizing profit, the profit, like these kinds of things. This is very important. Like the problem analysis part is very important. Then you will brainstorm a greedy choice. what we will brainstorm is, we will brainstorm a greedy choice. As like I already mentioned you, what is a greedy choice? Greedy choice is what is best at the moment. Like either choosing the time is best, either choosing like the particular ratio could be best. Like in the fractional knapsack type of a problem, we choose like the value per weight type of ratio. We will maximize this, sort this, and then we will choose this. So you have to brainstorm what you are making a choice. What is the greedy choice you are making? Like in the activity selection problem, we which activity ends the earliest, we brainstorm on that greedy approach. In the Huffman coding problem, we choose like the which two characters have the smallest frequency and then merge those and build up the solution. In the fractional knapsack type of a problem, we choose the item which has the highest value per unit weight, like the ratio we choose. Using that ratio, we slowly build up our problem. So the first step is problem analysis. Analyze what the problem is asking, then brainstorm a greedy choice, like what are the particular ideas you can brainstorm on. And the third is a very important thing, which is prove it. The most important step is prove it. Like you have analyzed the particular problem, you have brainstormed what the greedy choice. For example, you are going to minimize the cost, minimize the profit, minimize the cost. So you sort it, and then you slowly build the solution of the particular problem. But the most important step is how you can prove it. And this is the single most thing that will make a better competitive programmer from a beginner to the intermediates. This is the best step. And to prove it, we can't just say that this is that I'm feeling this is good and this is the bad. We can't do that. We are going to be very serious about this. And how can we serious about this? I will give you mathematical approaches. I will give you mathematical tools which are invariants and monovariants. We will discuss them later in this video. There we will discuss like how we can prove that mathematically, how we can prove that the particular algorithms which we are building to solve this particular problems are the best, are the correct ones. So the proving is very important, because the implementation of a greedy approach is very easy. As you if you guys have solved some kind of a problems of the greedy approach, you already know that solving them is very easy. The implementation part is very easy, but what is difficult is like the approaching to that particular solution, proving that the solution you are providing is correct. And that saves a lot of time in contest, that saves a lot of debugging time of during a contest, because during a contest the time is very important, time is very crucial. You have to slowly build up the temperament for problem solving, temperament for contest. And how you can build it? When you can build strong intuitions around proving things, because in competitive programming, in DSA, in your OAs and your interviews, you are mostly doing maths and like on pen and paper you are doing stuff. In your head you are doing stuff, because the implementation of these types of problems is not that of a bother, it's not that difficult. Things which are difficult is proving that your current approach is like the optimal and the best. That's the main thing. And the next step is implementation. It's like the easiest part of all of this. How you can like implement? You can sort the data, iterate through the data. You can use a data structure like priority queue or heap. Sometimes not just sorting will help you, like the priority queue or the heap will also help you during the implementation. So how you can like approach to a greedy problem, how you can solve it? First, problem analysis. Second, you brainstorm on the greedy choice. Third, you prove it. The problem understanding you develop like on what the problem is asking. In the second step, you brainstorm the choices, like these are the greedy choices, these are going to be my choices, I will build up the particular solution. Then I will prove it. Proving the particular solution is very important. Like proving saves a lot of time, proving saves a lot of implementation and debugging time. And then the final step is just implementation. Implementation, as you guys already know, it's the easiest part. You just sort the iterate and like the user data structure. We will use the implementation part in all the upcoming videos. We will do all of these things. So the implementation is going to be the very easy part. And the most important part that separates this course from rest of the course, why I'm saying this is going to be the best algorithm course, best greedy algorithm course you will ever find on YouTube or the internet, because nobody discuss about invariants and monovariants. Nobody is going to discuss you about how you are going to prove the greedy algorithms, how you are going to approach to that particular solution, and these things makes a better competitive programmers. These things makes you the best, like the best of the best. You become a beast in these kind of things. You understand what is going under the hood. You are not just guessing the solutions, you are providing the proofs of that particular solution. And these things, doing these things will at first when you start doing these things makes you a little slower, but eventually when you keep practicing you will be like super fast. You will be super fast and you will be very confident in what you are thinking. That's the very vital point in this. And as I already told you, like the problem solving does not have a approach to that particular problem. You don't know a approach to solve that particular problem, so you develop an approach and you have to also prove that particular approach so that you can be confident and you can without any hesitation you can submit your solutions to the platforms on whichever you are doing the contest. And these are the things that make you stand out in any kind of an interview, any type of a technical interview. You can stand out because you will have a strong mathematical foundations. So without wasting any more time, let's just discuss what are invariants and monovariants and how you can use them to prove your greedy approaches using a mathematical tool. These are the mathematical tools. These are not going to be the implementation types of your problems. So like a quick refresher, maybe some of you guys already know what are invariants and monovariants, but I will give you a quick refresher. What is this? Invariants are the quantities that never changes no matter what choices or steps you make. What are the invariants? Like you play tic-tac-toe, you have x's and zeros on it, so all the x and 0 always differs by at most 1. This property never changes. Like any step or choice you make, you start game, you make a 0, you make an x, you make a o, so the difference between them is always going to be 1. Does not matter what choices you make. So the in a very practical sense, what is an invariant? Invariant is simply a quantity which never changes, which is a fixed quantity which never changes. What is monovariant? Monovariant is something that changes in one particular direction. Either it increases or it decreases. It is it ensures progress and hence ensure progress. We will discuss what about the progress and all of these things, but the main point is what is an invariant? A quantity that is increasing or decreasing, like acceleration and like velocity. A moving car, you are speeding up the car, you are just moving up. That's like the monovariant thing. You are increasing your speed continuously or you are decreasing your speed. So the monovariant is that's a thing that always changes in one direction, either increasing or decreasing, always changes. Invariant is that never changes. So this is a very brief introduction of invariants and monovariants, how you can use them in your approaches, in your greedy algorithms, how you can use them. Let's just discuss this. Invariant in greedy algorithms. An invariant is a condition or property that remains true throughout the execution of an algorithm from start to finish. You start for a particular problem, you thought of an algorithm maybe I can use this particular greedy choice, and using that greedy choice I can minimize this, maximize this, or use a heap or priority queue and solve my particular problem. You make those choices. And so what is an invariant in that greedy property, in that whole of the situation of the problem, is that something that will remain true throughout the execution of an algorithm, which is true at the start of the algorithm, which is true at the middle of an algorithm, which is going to be true at the end of the algorithm, which is true from start to finish. This is very important property. I will give you an example later. In this video I will give you an example. We are just discussing theory, and I will guarantee you I will try to all the problems that are going to be I am covering in this particular course. I am going to cover them in a fashion I am going to give you invariants and monovariants, proofs of all using these mathematical tools, proof of all the greedy algorithms that we are going to come up with, so you can slowly build up to these intuition. Today I know we are just going with the theory of all of this, so maybe you will get them, maybe you will not get them, but this is going to be a like a game changer for all of you. So what is an invariant in greedy algorithms? A property or a condition that never changes from start to finish, it remains same. What is the purpose of this? Why are we doing this? So we use an invariant to prove that if we start in a good state, what is the purpose of this? The invariant is simply saying we will prove that if we start in a good state and our algorithm maintains this good state with every step, then when we finish, we must be in a correct state. That is, we have found an optimal solution. Like in the start, we are making a good choice. In the middle, we are making a good choice. At the end, we are making the good choice. Simply we are in a better state of our particular problem. So we can say that this property is not changing. So we have found an optimal solution for this. How we are going to do this? The proof strategy, how is going to do this? We initialize so that initialization show that the invariant is true before the main loop of the algorithms run. We first of all initialize what the proof strategy, in which we will initialize we start a loop of our algorithm at the start of when we have not even started the loop of our particular algorithms. So that particular quantity, that particular condition is true. Next we will do a maintenance, like in the partial loop, when we are in the loop, that property or that condition also stays true, still stays true. And when we finish that particular condition, like the termination, it stays true. Even then, I know you will be a little confusing, because if you know about the invariants, it will be very easy. But if you are looking at them for the first time and for the greedy algorithms, proving them using this, so it may be a little bit confusing, but it will clear up by the end of this video. I promise you that. Just remember, what are invariants? These are the properties that will not finish. What are the purpose of this? The simple purpose of this is we are doing an algorithm loop and we want a particular condition or a particular state to be true at the start, at the middle, at the end. At every point we want something to be true, so that we can make a better choice, we can make a better possible choice. And the proof strategy is simply initialization, maintenance and termination. Initialization, we state a particular condition that it is true before the loop. Termination, we state that it is true after the loop. And in maintenance, we state that it is true at every particular step of our algorithm. So that will be our invariants in greedy algorithms. Let's just quickly discuss about the monovariants. Then we will discuss an example, and that will solidify your understanding of these invariants and monovariants. The more solidifying condition for this will be you solve a little bit more problems. And I'm not saying you that you just start solving random problems. First, see the full course. I will be covering 15 to 20 problems. Cover all of those problems, and then we will discuss about all of these. Then you will be very much in a position to use these tools to prove your particular algorithm and to find a better greedy approach. And the implementation is going to be very easy. And let's just discuss what is monovariants in greedy algorithms. A monovariant or monotonic invariant is a quantity that changes monotonically, only increases or only decreases with each step of the algorithm. It is often measured as a progress. Simple. Monovariant, it defines a property which is increasing or decreasing throughout the algorithm. Our algorithm is running, and this property is either increasing or either decreasing. If a particular problem says we need to maximize the profit, so we want them to increase. It should be monovariant at each step. We have n items, we have to choose from these n items, and we have to maximize the profit. So we want to maximize the profit. So this profit at each step of our algorithm should be increasing at each step. So we can say that the profit is increasing. This property is monovariant, and this shows the progress. If it is increasing at each step, then we are progressing. We are choosing the best possible options at that particular moment. And with this, since our items will eventually terminate, so this also depicts this also tells us about the termination of the algorithm. We also get an idea that this particular algorithm is going to terminate at the end. It is going to be a termination at the end. So that's how the monovariant type of a thing helps us. Again, let's just read about something about this. The purpose of this is to prove that the algorithm must eventually terminate and to bound its number of steps. Simply bound its number of steps. we don't want the algorithm to run for infinity. We don't want that. We don't want the while loops to run for a lot of time. So it bounds the number of steps. It eventually terminates. That it shows, and it shows that every greedy move we are getting irrecoverably closer to the solution. Like every greedy move we are making, which I already told you about the profit example we discussed. We are making profit maximum. So we are always moving closer to the solution. That's the main point of all of this. We are always moving like towards the maximizing the solution. This is our main thing for the monovariant thing. And the proof strategy is going to be identify a quantity, example the number of unprocessed items, the remaining capacity, a potential function, कुछ भी anything can be happening there. Like we just identify a quantity which is the unprocessed items there, remaining capacities or the potential functions here. So show that the quantity strictly increases or decreases in every step, and argue that since the quantity is bounded, example if it can't be negative, it can't exceed the total number of elements, simply it is bounded, the algorithm must stop after a finite number of steps. The algorithm is going to stop after a finite number of steps. That's the main point of the monovariant in greedy algorithms. Like it bounds the number of steps, which eventually tells us the algorithm is going to terminate, and at each greedy step it tells like we are moving closer to our solution, we are moving closer to our final solution. That's the main important point of a monovariant property. Let's just discuss a example. So we will solidify our understanding of what is a invariant or what we are going with the monovariant type of thing. So the problem I pick up is the activity selection problem. We are not going to discuss about the implementations of these problems. We are just about the theory part, like how we are going to prove this. And when we discuss the problem separately, for each video I will discuss a separate problem, then we will discuss about these proofs in very much details. Today we are just having like a brief idea of what are these. I know these are difficult to get, so we will eventually build up to that particular moment when it will become easy for us. So for the activity selection problem, which is the interval scheduling problem, we given the activities with start and end times. We are giving some activities, and the activities have a start and end times. Find the maximum number of non-overlapping activities. We have to find the maximum number of non-overlapping activities. So the problem is very simple. For example, we are given some activities. The activities are given, and every activity is giving us like the starting and ending time. This is E2. For example, this is E3, this is like S4, E4. Simply S of I is representing the start time of the particular problem, and E of EI is like the end time of that particular activity. So maybe this type of the overlapping situation we can get. How we can maximize the non-overlapping conditions? As you can see, if you can do S2 E2 and then S4 E4, we can say that there are two activities which are non-overlapping. If we start with S3 and E3, we can go to S4 E4. Like say like S4 and E4 are there. So we if we start with the S3, we can't go to S4 E4, and if we start with the S1 E1, we have S4 E4, so we can have an answer 2. So we have to find the maximum non-overlapping situations here. And like this is a very like a famous problem. The activity selection problem is a very famous problem in the greedy approach. I'm not assuming that you already know the solution of this, and I'm not forcing you that you should know the solution of it by now. We will discuss it in the later problems. We will discuss it in very much detail. But the solution for this particular problem is we don't sort with start times. We don't stop with sort with start times. We don't make the greedy choice based on the start time of that particular activity. We make it using the end time, which makes the maximum possible solutions for us. We will discuss why the end times gives us the most overlapping solutions. We will discuss it later. Like in this particular example, you can also see S3 starting the very first, but it is ending very last. So with this, we are only going to make a one overlapping situation. But if we make it with E1, like E1, E2, E3. So E1 is sorted. So this is our first activity. We pick the second activity, which is the second minimum time. So we will not pick this because this will be the overlapping. We will not pick this. We will pick this. So based on this implementation, I'm not saying you should know the implementation, but the start time we don't sort with this. We sort with the end time, and we like the greedy choice or the greedy strategy for solving this particular problem will be To like sort the activities by end time, always pick the activity that ends earliest and it's compatible with already chosen ones, which we already discussed. And how we are going to prove that this particular this particular solution which we discussed, like sort activities by end time, is going to be like the correct solution, which is going to give us the correct solution. So here we discuss about the invariant and monovariant. So what is the invariant at this particular problem? What is the one thing that is not changing here? So that at any point the set of chosen activities is always non-overlapping and optimal for all activities considered so far. So the what is invariant? The problem said all the activities should be non-overlapping, and we are holding that property. It should be non-overlapping, and at each step it should be the optimal for each condition. All the activities should be considered. We will get the optimal solution. And what is going to be the monovariant here? The finishing time of the last chosen activity strictly increases, and as you already like seen, E2, E3, E4, they are always increasing. So it ensures the progress and termination. It ensures that we are going to eventually terminate the situation. The algorithm is eventually going to terminate, and the E1, E2, E3, they are like at each step they are strictly increasing. So we will finally get to our final solution. So by consciously thinking about invariants and monovariants, you move from guessing, I think that taking the end time will work, to rigorously reasoning. I can prove that taking the time is always safe and the algorithm will finish. This is a core skill of a strong competitive programming, which I am telling you from the start, and this is a very important property. Using the monovariants and invariants, we can prove that the particular greedy approach that we just discussed is the correct approach. It is a good practice. I'm not saying that you should do in all the problems. If you take my advice, do it in all the problems. Start thinking about the mathematical approaches of those problems. I'm like telling you to follow the whole series, to follow all the questions step by step. We will build up all those intuition, and we will do this mathematical approach also. And now how to use this in problem solving, the monovariant and invariant, how you can solve this in problem solving. So look for an invariant. Which property do I have to preserve at each greedy step? जो भी मैं like whatever greedy step I am taking, what is the property I have to preserve? We will discuss about this, like what at every greedy step, like I'm going from one step to other step, what is the property that should be preserved? Like in the activity selection problem, it should be non-overlapping and it should be optimal. The optimal situation is like true for everything, but we should pick the non-overlapping situation. So we took that as an invariant, and we will like optimally choose a problem that is not change that, and look for a monovariant. What quantity is always moving in one direction, which ensures progress and termination. Like in a profit kind of a situation, we want the profit to increase every time. In the above activity selection problem, the E1, E2, E3, like the end times are increasing all the time. So that depicts like the termination and the progress of a particular problem. And this is how you prove greedy is correct instead of just feeling it's correct. Like we just say in the greedy approaches, we just say like I'm feeling that this will be the correct result. So you move from that feeling like this is a correct to actually with reasoning, with proper mathematical tools, you can give that particular implementation that this is correct. And like believe me, if you show your interviewers, if you tell your interviewers about invariants and monovariants, you prove them mathematically, bro, you are going to get the job. There's no one you just stand out of the crowd. Nobody does that. And so a mental trick for the contest, when you are giving contest, you should like a mental trick you can use is when thinking about greedy, invariant question should be what must remain true no matter what, and the monovariant question would be what measure is always improving toward goal, what measure is going to take me toward the goal. And if you can answer both, greedy is very likely correct. So that's like the main whole theory about the greedy approach. I think like you get that theory of greedy, how we are applying, how we are going to use greedy, how we are going to solve the problems of greedy. I told you that no theory is going to help you, like no theory is going to help you, not like for the greedy you like make different algorithms, you make different choices, how you make those choices, like invariant choices, like based on the choices you depict like this is an invariant type of a quantity, I want this to be true at every step. Then you discuss about the monovariant type of quantity, like I want this to be increasing or decreasing at each step, that depicts the progress and the termination of a particular problem. These make this these two things will help you make better decisions, better choices, better decisions, whatever you want to say. These are going to help you make those better choices, better decisions, and which will eventually help you build the intuition and the problem solving skills you need. So that's the particular greedy approach, which is very famous. And if you like this video, and if you want me to continue this series, if you want me to fast forward this series and complete this very fast, just hit the like button, comment what you want with this particular series. If you like the theory of all the greedy approaches, I promise you don't get this on the internet. This is very unique stuff I am giving you. And please share it with your friends. If you share it, the subscribers, the likes and the views increases. This help us in the motivation type of a thing for me. And please do subscribe to the channel. I will bring more and more videos about this. I will finish the greedy approach, then we will start constructive approach, and follow all the videos, follow all the content, all the problems that I'm going to discuss in this particular section in this greedy approaches. And so that's it for this video, and have a nice day. See you in the next video.